Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about nanoparticles or nanomaterials introduction of nanomaterials and preparation of nanomaterials by sol gel method. So what is nanomaterials? So in recent years, this nanomaterials is the most important, or nanotechnology is the most important and developing fields such as science and engineering and biomedicine, bioscience. So in this case, it plays an important role in medicine, electronic or other fields also. So here, first, what is meaning of nano? So it is derived from Greek. Nano means dwarf or small. So it is a small materials. So the prefix nano means 1 billionth. 1 billionth, that means 10 to the power minus 9. So therefore, the nanometer is the 1 billionth of a meter. So nanomaterials or the study of nanomaterials is called nanotechnology. So in recent years, this nanotechnology plays an important role in developing in fields such as science and engineering and biomedicine, etc. It plays an important role. So here, what is the meaning of nano? From the Greek, nano means dwarf or small. So the prefix nano means 1 billionth. That means 10 to the power 9 meters. It's equal 1 angstroms. 1 angstrom equal 10 to the power 9 meters. So this nano means 1 billionth of a 1 billionth or 10 to the power minus 9. Therefore, 1 nanometer is 1 billionth of a meter. So nanoparticles are these particles sizes between 1 to 100 nanometers. This nanoparticle size is in between 1 nanometers to 100 nanometers in size. 1 to 100 nanometers. So these nanoscale materials are defined as it is set of substances. These nanoscale materials are defined as a set of substances where at least one dimension is less than approximately 100 nanometers. Less than approximately 1 to 100 nanometers. So a nanometer is a 1 billionth of a millimeter. It approximately 1 lakh times smaller than diameter of a human hair. So it is very difficult to see. We cannot see our own eyes with this nanomaterial because this nanomaterial size is very small. That is, the size is between 1 nanometers to 100 nanometers. So these nanometers are very interesting because at the scale of unique optical, magnetic and electrical and other properties emerge. So it plays an important nowadays. We most prefer this nanomaterial. Why? Because these are having unique properties, unique optical, magnetic, electrical and other properties emerge. So these emergent properties have the potential. Emergent is unbelievable. So these emergent properties have the potential for great impacts in electronics, medicine and other fields. So that's why we most prefer these nanomaterials in recent years. Now let's discuss nanoscale. So nanoscale is an incredibly small scale of measurement. Nanoscale is an incredibly small scale of measurement. So it describes objects, process and phenomenon that measures less than 100 nanometers in size. So already we know that nanoparticle size in between 1 nanometers to 100 nanometers. So it is explained in this nanoscale. So nanoscale is an incredibly small scale of measurement. Small scale of measurement. So it describes objects, then process and phenomenon so that measures less than 100 nanometers in size. So already we know that nanometer is the 1 billionth of a meter. Nanometer is a 1 billionth of a meter. So which means that the nanoscale is incredibly small. Incredibly small. So the prefix nano means 1 billionth. That means very small. So it's equal 10 to the power minus 9 meters. So therefore 1 nanometer is 1 billionth of a meter. So it is very difficult to imagine just now just how small that is. We can't see for our eyes. That is very small materials, is nano materials, and plays an important role in science and engineering and medical fields also. So here some of the examples given in this nanoscale. So here, for example, this ball, we can see this. The size is 1 centimeter. For example, ant, its size is 1 millimeter. We can see this. And here human hair. Human hair. So what is the size on this nanoscale? 100 micrometers. 100 micrometers. We can see this. And here, for example, bacteria. This is a 10 micrometers. And here virus. It is a 1 micrometer. So these are we can see. So but here DNA and molecules or atoms, this ranges between 1 nanometers to 100 nanometers. We cannot see these atoms or molecules DNA because these are very small. We cannot see our own eyes, but we can see by using the microscopes only. That means this particle size is very small. So this nanoscale is incredibly small scale of measurement. It describes the objects, process and phenomenon that measures less than 100 nanometers in size. So nano means it is a 1 billionth or 10 to the power minus 9. So the nanoparticle size is in between 1 nanometers to 100 nanometers. Here it given some examples in this explained by this nanoscale. So what is nanomaterial? Just now we discussed already. So the materials of at least one dimension. The materials are at least one dimension between 1 nanometers to 100 nanometers are known as nanomaterials. 1 nanometers to 100 nanometers. The particles are nanoparticle size in between 1 nanometers to 100 nanometers is called nanomaterials. They are very small materials and plays important role in growing technology. So what is the meaning of nanoscience? So the study of materials and their properties. The study of materials and their properties at the length scale of few nanometers is called nanoscience. The study of materials and their properties at the length scale of few nanometers is called nanoscience. So what is the meaning of nanotechnology? So simply we say the study of nanomaterials is called nanotechnology, and this nanotechnology plays an important role and developing fields in science and engineering technologies and biomedicine. So it plays an important role in that fields. So the techniques involved in the preparation, characterization and use of the properties of nanomaterials in different applications are collectively called nanotechnology. So what is nanotechnology? The techniques involved in the preparation, characterization and use of the properties of nanomaterials in different applications are collectively called nanotechnology. We can synthesize that material and we can use different applications. So the study of nanomaterials is called nanotechnology, or otherwise it is design, characterization and production and applications of structures, devices and systems by controlling their shape and size at nanoscale. It is also called as nanotechnology. So nanomaterials means the nanoparticle size in between less than 1 nanometers to 100 nanometers is called nanomaterials. The small particle size is very small. And nanoscience means the study of materials and the properties at the length of few nanometers is called nanoscience. Nanotechnology means the techniques involved in the preparation, characterization, and use of the properties of nanomaterials in different applications is known as nanotechnology. So now let's discuss most importantly synthesis of nanomaterials. So there are two methods for preparing nanomaterials. So we can synthesize this nanomaterial by using two types of techniques. One is top-down approach and another one is bottom-up approach. So there are two methods of preparing nanomaterials. One is top-down approach and another one is bottom-up approach. So we can synthesize this nanomaterial by using these two methods. So first one is in top-down approach. So top-down approach, in this case the material is reduced from bulk size to nanoscale. In this top-down approach, the material is reduced from bulk size to nanoscale. That means macro to micro. For example, in this top-down approach, we are preparing nanomaterials by using this. It's including ball milling method and nanolithography. Best example of top-down approach is ball milling method and nanolithography. So in this top-down approach, the material is reduced from bulk size to nanoscale. For example, see this image here in this top-down approach. So here bulk material, the size, the particle size is very high. So bulk down of the material, we can convert it into nanostructures. So the bulk material is reduced from bulk size to nanoscale, from macro to micro. So this is called top-down approach. This is called top-down approach. So the nanomaterial synthesized by using two types of methods, top-down approach, bottom-up approach. So top-down approach, here the material is reduced from bulk size to nanostructures. Bulk size to nanoscale, that means macro molecules converted into micro nanoparticles. This process is called top-down approach. So best example of top-down approaches are ball milling method and nanolithography. And second method is in bottom-up approach. In bottom-up approach. So here the matter in atomic or molecular level. The matter in atomic or molecular level. For example, you see atoms or molecules. So it is the bottom-up approach. Here that means micro to macro. Micro to macro. So in this bottom-up approach, matter in atomic or molecular level gets assembled to form tiny clusters. Assembled to form tiny clusters. So which grow into reach nano size. So this micro to macro. Simply its best example is brick to building. Brick to building, the best common example. So in this case, in bottom-up approach, matter in atomic or molecular level gets assembled to form tiny clusters. So this cluster which grow to reach nanoparticle size or nano size. So simply say micro to macro, bottom-up approach. So examples of bottom-up approach are chemical vapor deposition, salt gel method, or physical vapor deposition, or chemical reduced synthesis method. So this nanosynthesis of nanomaterials, these nanomaterials are synthesized by using two types of techniques, bottom-up approach and top-down approach. So in this top-down approach, bulk materials to nanoparticles, that means macro to micro. So in this is including ball milling method and nanolithography. And second type technique is bottom-up approach. Bottom-up approach. So in this case, matter in atoms or molecule levels gets assembled to form tiny clusters. It grows into nano size. This method is called bottom-up approach. It's including the best example is chemical vapor deposition and salt gel method, chemical reduced method, or physical vapor deposition, etc. Best example of bottom-up approach. So in this way, we can synthesize nanomaterials by using these two types of techniques, top-down approach and bottom-up approach. So in this image, it is clearly shows that this is the bulk material. So we can synthesize in this top-down approach. So bulk to small or nanoparticles. So it's including mechanical milling, etching, laser ablation, splattering, electro explosion. So these methods are including under these nanoparticles are prepared in this top-down approach. That means macro to micro, bulk material to nanoparticles. And second method is bottom-up approach. It's including best example is supercritical fluid synthesis, spinning, Solzal process, laser pyrolysis, and chemical vapor deposition, molecular condensation, chemical reduction, and green synthesis. So in this method, we follow is this bottom up approach, micro to macro. Micro to macro, that means atoms or molecules, the matter in atoms or molecular level, then growing into form clusters. That means the size increases, and again this clusters goes to this nanoparticle size. So this is the bottom up approach, and this is the top down approach. We can synthesize nanomaterials in this type of two methods. So now let's discuss nanomaterial synthesized by salt gel process. It is the most important technique for synthesis of nanomaterials. So nanomaterial synthesis by salt gel process. So in this salt gel process, the main principle involved in this salt gel method is conversion of precursor. This is the most important. The conversion of precursor solution into gel. The conversion of precursor solution into gel via hydrolysis and condensation reactions. So first of all, here nanomaterial synthesized by salt gel process. The main principle involved in this salt gel method is the conversion of precursor. Precursor means starting material. Starting material. So the conversion of precursor solution into gel. The solution into gel via hydrolysis and condensation reactions. Via hydrolysis and condensation reactions. So this method is the salt gel method is mainly used for preparation of metal oxide nanomaterials. Metal oxide nanomaterial synthesis purpose mainly we prefer this salt gel method. So what is the principle involved in this? The precursor, this is starting material, precursor solution converted into gel via hydrolysis and polycondensation reactions takes place here. And the best example is zinc oxide nanoparticles and titanium oxide nanoparticles can be synthesized by this method. Best example of this salt gel method is zinc oxide nanoparticles and titanium oxide nanoparticles we can synthesize by using this salt gel method. So it is a good example of bottom up approach, micro to macro. This is the best example of bottom up approach. It is a wet chemical technique. Why we call this a wet chemical technique? Because all the substances which are used for this method is in wet condition only. Here water acts as a catalyst. So all these are taken in wet condition. That's why this method is called wet chemical technique or salt gel process. So once again repeated here, this main principle involved in this salt gel process, the precursion of salt convert into gel via hydrolysis and condensation reaction. Condensation reaction. It is the best example of bottom-up approach, and this method is mainly used for preparation of metal oxide nanoparticles. The best example is zinc oxide nanoparticles and titanium oxide nanoparticles. So here salt converted to gel. Next it is dried, then grind, and finally you'll get final product. So how to convert this salt into gel and how can we prepare these nanoparticles by this salt gel method? So here the following steps are involved in the synthesis of nanomaterials by salt gel process. So what is the first step one? Preparation of salt. Preparation of salt. So in this method, metal alkoxide used as a precursor. So precursor means it is a starting materials. So here in this preparation of metal oxides, the first step is involves so many steps. So it's in first step is preparation of salt. So in this method, metal alkoxide used as a precursor. That means metal alkoxide is the starting material. So it is used as a precursor to synthesize nanoparticles of a metal oxide. So here metal alkoxide is dissolved in alcohol. It is dissolved in alcohol and the water is added under acidic, neutral and basic conditions. So the addition of water leads to hydrolysis in which alkoxide ligand is replaced with hydroxyl ligand. So what is the step one? Preparation of salt. So that purpose we are using starting material, that means precursor is metal alkoxide. So this metal alkoxide is dissolved in alcohol. So in this case, it forms homogeneous system. It is formed. So this metal alkoxide dissolved in alcohol, and then we are adding water added under acidic, neutral, or basic conditions. So in this case, the addition of water it leads to hydrolysis. So in which this is a alkoxide. So when we are adding water in this alkoxide is the precursor. It is a precursor. So when we are adding water in this alkoxide, so this alkoxide ligand is replaced with a hydroxyl ligand. So alkoxide ligand is replaced by hydroxyl ligand through this process hydrolysis. Next one is conversion of salt into gel. First is the preparation of salt. That purpose we are taking metal alkoxide. Alkoxide dissolved in alcohol and adding water. Here water acts as a catalyst. Water acts as a catalyst. So all they are taking wet condition. That's why this reaction is also called as wet chemical synthesis. Wet chemical synthesis. So in this case, you can prepare salt via hydrolysis. So next one is conversion of salt to gel. So the polycondensation reaction between metal hydroxide and metal alkoxide. Metal hydroxide and metal alkoxide. So the results in the formation of oxide or alcohol bridge network. That means it is a gel. So that leads to increase in the viscosity of the solution. So in the conversion of salt to gel, gel is a colloidal substance. It is a water and solvent we are taking here, water and alcohol. So it is a colloidal or heterogeneous system. But here, first step is the homogeneous system. So in this conversion, how to convert the salt into gel? The polycondensation reaction between metal hydroxide and metal alkoxide. Metal hydroxide and metal alkoxide. So metal hydroxide, metal alkoxide. So the result in the formation of oxide or alcohol form bridge network gel. This is the gel. So in this case, that it leads to increase the viscosity of the solution. It is all converted to gel. In this case, viscosity is increases. So these two steps carried out by hydrolysis and polycondensation. Via hydrolysis and polycondensation. During hydrolysis, it forms salt. Then during condensation, it converts salt to gel. So in this picture, it is clearly shows that. So first starting, we are taking in this beaker metal alkoxide. It is a precursor. So here precursor is the metal alkoxide. Metal alkoxide dissolved in alcohol Then we are adding water. So it is a homogeneous system. Homogeneous system. Then during hydrolysis, it forms sol. It is a sol formation. It is a colloidal structure in sol due to this alcohol and water. Next, it is converted to gel through via here. This is the hydrolysis, and here polycondensation. Polycondensation. Salt converted to gel. So first step is hydrolysis. When we are adding this precursor solvent, then it forms salt. This is via hydrolysis. And next step 2 is the condensation. That means salt converted to gel. And third step is the aging and drying. So what is aging? So aging of the gel. So here the reaction mixture is allowed to continue polycondensation reaction. So until the gel transformed into solid mass. So aging of the gel means the reaction mixture is allowed to continue polycondensation reactions. So until the gel transforms into solid mass. The thickness is increases more. That means evaporation of solvent. Evaporation of solvent. This is called aging of the gel. And next one is removal of solvent or drying of gel. So the water and other impurities or other volatile liquids, or water are removed from the gel network. We can remove water or other volatile liquids. We can remove from this gel. This is called drying of gel. So drying takes place by three different ways. So if this gel is isolated by thermal evaporation. Isolated by thermal evaporation. So the resulting product is termed as zero gel. Zero gel. If the gel is the solvent is extracted under supercritical conditions. This purpose we are using special equipment. So we are heating under supercritical conditions. So the resulting product termed as aerogel. Aerogel. The final step is here heat treatment. So the sample obtained in calcinated at high temperature, that is 800 degrees centigrade temperature, to obtain nanoparticles. So the nanoparticles formed by this Sol-Gel process, it is commonly the size ranging is from 1 to 100 nanometers. So here, so what is the step 1? Preparation of salt. So first we are taking in this beaker metal alkoxide as a precursor. It is dissolved in alcohol. Then we are adding water. So it is a hydrolysis step 1. Then it forms salt formation. It is a colloidal structure in salt. That means the water and alcohol. It is a colloidal structure formed via hydrolysis. This is a salt preparation. Next, step 2 is condensation, polycondensation. So in this case, salt converted to gel. That means the thickness of the gel is increased via polycondensation. That means water or any solvent is evaporate. The thickness is improves in this gel. Next, heating, drying of this gel by 3 different ways. So one is supercritical drying and thermal drying and freeze drying. So in this gel is supercritical drying, heating it at supercritical temperature point. That means this purpose we are using some special equipment. It is very expensive, but we get correct size and particle size and shape of the nanoparticles obtained in this method, supercritical drying. But it is very expensive. That's why we less preferred. So in this case, the product is called aerogel. Aerogel. Next, this gel is thermal drying. Thermal drying. The product is called zero gel. Zero gel. But in this case, we cannot get exact size and shape of nanoparticle. So that's why we less preferred. The morphology is changed here. Particle size is changed. And third one is freeze drying. So here, this gel is heated high temperature. The sample is heated high temperature, that is 800 degrees centigrade temperature. Heating it, then it forms cryogel. Cryogel. So it is most preferred method, and it is less expensive. It is less expensive. That's why I prefer more this one. So heating at 800 degrees centigrade temperature, then it finally get final product is nanoparticles. So nanoparticles prepared by which method? Salt gel process. It is also called as wet chemical synthesis. So all we are taking wet condition, and here water acts as a catalyst. So for this method is followed by the hydrolysis and polycondensation reaction. So during hydrolysis reaction it forms salt. Next, polycondensation, it forms gel. So after aging and drying, we can synthesize the final product of nanomaterials. So in supercritical drying, we are preparing the sample product is called aerogel. Thermal drying, the sample is called zerogel. And freeze drying at 800 degrees centigrade, cryogel, which is the most preferred method and less expensive. So that's why I prefer this method. And finally, we'll get nanoparticles synthesized by this salt gel process via hydrolysis and polycondensation. So here also same precursor. This is starting material. We are taking in this precursor alcohol and water. Then it form salt. Then it converts to the gel dehydration via polycondensation reaction. So this gel is rapid heating. It forms aerogel, and heating at critical temperature that form zerogel, and calcinated then form nanoparticles powder at 800 degrees centigrade temperature. So in this way, we can prepare these nanoparticles by using this salt gel process. So now let's discuss what are the advantages of salt gel process. So the main advantages of salt gel process are the high purity of the product. The purity of the product is very high. And narrow particle size distribution, the very small particle size. Already we know that nanoparticle size is 1 to 100 nanometers, in between 1 to 100 nanometers. So in this salt gel method, we can synthesize nanoparticle size distribution. Size of the particles we can synthesize in this salt gel method. And the achievement of uniform nanostructures at low temperature. You can achievement of uniform nanostructures at low temperature. These are the main advantages of salt gel process. One is high purity of the product we can synthesize in this, and nanoparticle size distribution, and the achievement of uniform nanostructures at low temperatures. But what is the disadvantages of the salt gel process? So the cost of the raw materials may be high. Which chemicals used for the synthesis of these nanomaterials, maybe that cost is high. What are the applications of salt gel method? So the materials obtained from the salt gel methods are used in various optical, electronic, energy and surface engineering, biosensors and pharmaceutical and separation technologies such as chromatography. So in this case, we are using this nanomaterial which are synthesized by salt gel method. So in this session, we learned about what is nanomaterials, how can we synthesize these nanomaterials via top-down approach or bottom-up approach. So in this, we discussed in this session mainly how can we prepare these nanoparticles by salt gel method. So already we know that the salt gel method is mainly used for preparation of metal oxides. Mainly we synthesize zinc oxide, titanium oxide, nanoparticles synthesized in this salt gel method. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.